Today, we're going to be talking about separating mixtures, pages 618 to 621 of your science book. Separating mixtures. Suppose you really don't like olives. How are you going to get them off that deluxe pizza your friend ordered? Sometimes you need to separate the components of a mixture. Mixtures are not always easy to separate, but since mixing is a physical change, each component in a mixture keeps most of its physical properties. Physical properties such as color, size, melting point, boiling point, density, and ability to dissolve can be used to separate mixtures. Separating a mixture can be very simple, or it can involve several complex steps when one method is not enough. Density. Every substance has its own density. A less dense substance will float on a denser substance. Objects will float in water if they are less dense than water. They will sink if they are denser than water. Looking at the question on the bottom of page 16, what property was used to separate the items on this tray? We can see that the cubes are at one end and the marbles are at another end. So they were separated by shape. When one isn't enough. Sieve or mesh screen. A sieve or a mesh screen has holes that matter can pass through. Matter that is smaller than the holes pass through the mesh screen, while matter that is larger than the holes stays above a mesh screen. Think about the guy that went mining for gold. He would use a screen and keep the gold at the top and the sand would float to the bottom. Magnetic force. A magnet attracts matter that contains iron, separating it from other parts of the mixture. So, a magnet can take away bits of iron, as seen in the picture on the top of page 619. Filtration. A filter works like a mesh screen with very tiny openings or pores. Only the smallest bits of matter, like water particles and dissolved particles of salt, can pass through the pores. Think of it like a coffee filter. That's a filtration. Evaporation or boiling. Boiling is when a liquid rapidly changes to a gas at the boiling point of the liquid. Evaporation also changes a liquid to a gas, but it occurs as temperatures below the boiling point. During these processes, only the liquid particles leave the solution, dissolved particles stay behind. And the picture on the side, the water is boiled away and only the salt and water combination is left behind. Page 620, proportions and properties. When you make lemonade, it's important to get the amounts of lemon and sugar right. If it's too sweet or too sour, it doesn't taste right. How do proportions affect the properties of a mixture? Mixtures of metals are called alloys. The properties of the alloy depend on how much of each metal is in the mixture. Chemists first decide on the properties they need their alloy to have. Then they decide how much of which metals will be given to them and those properties. Steel is an alloy. It is made from iron and other substances. Different substances give steel different properties. For example, adding chromium will make steel shiny. Metals such as nickel and titanium can keep it from rusting. Carbon is often added to steel to make it stronger. Other substances help steel used in tools to stay sharp or keep from wearing down. To make an alloy, metals and other elements are melted together and then allowed to harden.
Humans are great, aren't they? I mean, I know I'm biased, being one myself and all, but people have been responsible for creating some pretty amazing materials. Materials like the ones that are in the computer or the tablet you might be watching me on right now. And we're inventing brand new materials all the time. Hey humans, keep up the good work. But what about materials that have already been invented? Can we do anything to improve those? And if maybe this time with a more modern example. Let's see how a material that we use all of the time can be altered and improved. In animation form, of course. Say hi to little Sabrina. Look at her tiny, cute cell phone. Part of little Sabrina's cell phone is covered in a material you should be familiar with. Glass. When cell phones were invented, glass coverings were applied to their screens to protect them. But as newer, better cell phones were invented, newer, better glass began to be used in our phones. The piece of glass that covers little Sabrina's screen now is not the same kind of glass that would have covered her screen in the late 1990s. This sheet of glass on the left is the kind of glass that covered older cell phones. Think phones that came out before the first iPhone. The sheet of glass on the right looks identical to the sheet on the left, right? But it's not. It's something called Gorilla Glass, which is on little Sabrina's current cell phone and covers most phones today. So they look the same. But how did this become this? If you're thinking gorillas have something to do with making this glass, you're about to be real disappointed. Material. How? Well, you know I don't like to answer a big question without a quick recap first. Before we talk about improving materials, let's recall what a material is. Simply put, a material is an object that's made of matter. And all materials have properties. Properties are... anybody? Anybody. Okay, fine, I'll remind you. Properties are the qualities of a certain kind of matter, like its color, shape, size, temperature, or weight. So, properties help describe materials. For example, this desk is an object made of matter, so it's made of a material. It's brown, medium size, weighs maybe a couple of kilograms. Those things I just listed are the desk's properties. Got it? Great. I'm going to answer the first part of our big question a little early and tell you, yes, humans can improve existing materials. In fact, there's a whole branch of science devoted specifically to studying the properties of materials and how to make them better. Scientists of thing are called, you'll never see this coming, materials scientists. Humans have been improving existing materials for a long time, since at least the 11th century. Back then, some early materials scientists discovered that the widely used material of iron could be improved. They found that by heating iron in a furnace with charcoal, they could turn iron into a different material we still use to this day. You might have heard of it. It's called steel.
Just like changing a recipe for food, the recipe for iron was changed to produce a new, harder, and longer-lasting material called steel.
Just looking to develop tough, scratch-resistant glass for people like me who drop their phones all the time, decided to give original glass, well, a bath. They dipped the less strong, crack-prone glass in a hot solution of potassium. The solution's extreme heat caused larger potassium particles in the solution to replace smaller particles of sodium in the glass. This exchange of particles changed the properties of the original glass, giving it more strength and making it less likely to crack. In the end, the bath gave scientists, and little Sabrina, Gorilla Glass. So the original material, the regular strength glass, was improved when its properties were changed. Which means, yes, humans can improve existing materials when they change the material's properties. This change can occur by adding new substances to a material, like the potassium particles in the glass, or by taking away some of its original substances, like the sodium particles. And this change in substance also changed the material's properties. So, to the scientist who invented Gorilla Glass, I and all of the other phone droppers out there give you our deepest thanks.
All right, for our last page today, we're looking back in our book to page 221. For each steel object on this page, list at least 2 properties that the steel must have. So if you look at the part on the right, you can see the properties are listed that you have to choose from. Is it bendable, strong, able to be heated, shiny, able to put into different shapes, heavy, flexible, resists damage, rust resistant, or thin? The first picture that we see is a tea kettle. And as I'm looking through the words on the right-hand side, I can say that a tea kettle is shiny, it can be shaped, and it resists rust. Wouldn't be too good to drink out of a tea kettle full of rust. Our second picture is a sculpture. Now this sculpture is something that is staying outside. It almost looks like a flower. So obviously it's bendable. It is very shiny. And it needs to be able to resist damage from the outside elements. Our last picture is a steel building frame. Now, buildings are often made of steel frames, and you can see there's a little bit of rust on them, but the rust is okay because they're going to be covered with the outside of the building. However, steel is stronger if it has enough iron in it. And so we need to say that this is a very heavy piece of steel, so heavy is one of them. it can resist damage, and it's extremely strong. Finally, we're looking at the section that says do the math, and we're going to skip this section. But when looking at the different kinds of steel that are here, each thing is a recipe to make the right kind of steel for the right application. Is it going to be building a building? Is it going to be used for something that is heating something up? So the correct recipe needs to be followed, and those are specific properties.